Hello everyone, welcome to our presentation on the environmental monitoring and alert system with cloud integration and mobile app. This project was undertaken as part of our instrumentation and calibration course unit. So today we will walk through the components, the working principles, demonstration and functionality of our system, and showcase our Android app for remote monitoring. Our projects aim to monitor environmental parameters such as temperature, humidity, air quality, and light intensity in real time. So the system features ESP32 microcontroller, a variation of sensors, real-time data display, cloud storage, and the remote monitoring capability via the mobile app. So we begin with the components and the sensors which we are using in the system. First, we can see the 6x2 I2C LCD display, which is used to show the real-time sensor data, which allow users to quickly view the environmental parameters. And then we can see the micro SD card module, which storage the sensor data locally for our historical analysis, which is useful for tracking the environmental changes in over time. And then we can see the core of our system, which is ESP32 module, which process the sensor data and enables the wireless communication, which send the data to the cloud for the mobile app for remote monitoring. Then we can see the LDR, which measure the light intensity by changing its resistance based on the amount of light fading on it and allow us to monitor the light levels. Then we can see the MQ135 sensor, which measures the air quality by detecting the gases like carbon dioxide, ammonia, benzene, and also the smoke, which that obviously help us to ensure air purity. And we can see the green and red LEDs, which provide us visual alerts when any of the environmental parameters exceed the predefined thresholds. Then we can see the DHT22 sensor, which measure the temperature and humidity with high accuracy, makes it stable for monitoring the environmental conditions. Finally, the buzzer, which provide the auditory alerts when any of the environmental parameters exceed the predefined threshold. So then the working of our system can be broken into several steps. First, DHT22 sensor, which measure the temperature and humidity, the MQ135 sensor, which measures the air quality, and the LDR measures the light intensity. These sensors send their data to the ESP32 control unit, which the ESP32 processes the data which received from the sensors and the real-time data displayed on the 6x2 I2C LCD, which shows the current environmental conditions. And also the data is also saved in the micro SD card for local storage and enable us to have the historical recorded data in environmental parameters. So ESP32 sends the data to the Firebase database in the cloud, allowing to the data to be accessed remotely via the mobile app, which provide users with real-time monitoring capability from anywhere. If any of the sensors reading exceed the set thresholds, the ESP triggers the buzzer and the LEDs. This immediate the alarm system, which help to take in prompt action to provide the potential issues. In addition to our hardware setup, we have also developed the Android app, allow the remotely monitoring our environmental parameters. The app which displays the air quality, humidity, light intensity, and the temperature values in real time, which are featured from the Firebase database. The app shows live data like live updates through the temperature, humidity, light, air quality, and light intensity, providing users up-to-date information on environmental condition in features clean and intensive interface, making it easier to users to navigate with the while monitoring the data. Now let's get the live demonstration of our system. First, observe the sensor collecting data from the real-time reading displayed in the LCD, which watch as the data transmission to the cloud using ESP32 wireless module, and see how the data can be accessed via the mobile app. Open the Android app and show the real-time data being updated, and highlighted the user interface and explain how user can view parameters, and then finally trigger the alarm by manipulating sensors reading and observe the buzzers and the LED activity, and then which including the branch of the set of thresholds. In conclusion, our environmental and alert system with cloud integration and mobile app providers the efficient way to monitor manage environmental conditions, which with real-time data display, cloud integration, and a robust alarm mechanism. This system can be utilized in various applications such as greenhouse, survey rooms, residential monitoring. So the accomplishing the Android app enhance the system stability of by providing the remote monitoring capabilities. Thank you for watching.